So you're building an AI device. Every single component choice you make is critical. But one of the most fundamental ones, the system memory, can be surprisingly tough. We're always told that newer is better, faster is better. But today, we're going to poke a little hole in that idea and find out why the latest and greatest might not be the smartest choice for your edge AI project. You've got your two options, right? DDR4 and DDR5. On the surface, it just looks like a simple upgrade. But as we're about to see, for these specialized edge AI systems, the obvious choice could actually be the totally wrong one. So what is really going on here?
All right, let's meet our contenders. In one corner, you've got DDR4, the stable, mature workhorse that's been the backbone of embedded systems for like a decade. And in the other corner, DDR5, the new, high-performance specialist, built from the ground up for these crazy, data-heavy workloads. This isn't just old versus new. It's about what makes the most sense for the heart of your AI device.
To really get why this choice is so important, we have to talk about a hidden bottleneck in AI devices. It's something that most people don't even think about, but it can absolutely make or break your project. And yeah, it has everything to do with memory. Just think about how your PC works. It's really just a series of sprints, isn't it? You open an app, boom, there's a burst of activity. You scroll a web page, another burst. But in between, the system RAM, it gets to catch its breath. It's a world of short, intense efforts.
Now, an edge AI device, that's not a sprint. Oh no, it's a full-on marathon. It's this relentless, non-stop river of data, from cameras, sensors, AI models, all flowing through the RAM constantly. It's under a heavy, sustained load all day, every day. And that, right there, changes everything.
All right, with that picture in your head, let's get under the hood of these two technologies. We're going to skip all the marketing hype and just focus on the core differences that an engineer, a system designer, actually needs to know to make the right call. First up, DDR4. This is the fourth generation of double data rate memory, and it has been the go-to for years. Why? Well, because it's stable, it's reliable, and there's a massive ecosystem built around it. If you've touched an embedded system in the past decade or so, you know DDR4.
And then we have DDR5, the new kid on the block. And it was specifically designed for the challenges we face today, like AI. It's all about handling more data, faster, and juggling more tasks at once, which is exactly what that constant stream of data in an edge device needs.
So we've got the reliable veteran and the high-speed newcomer, but how do they actually stack up? Let's break it down by the three things that really matter when you're designing a system: speed, size, and of course, how much it's going to cost you.
Now, this is where things get really interesting, that raw performance jump. Straight out of the gate, a baseline DDR5 module offers about a 50% increase in theoretical bandwidth over a fast DDR4 module. For an AI pipeline that's just starving for data, that is a massive, massive leap.
But you know, it's not just about being faster, it's about being smarter. Think of it like adding more lanes to a highway. A single stick of DDR5 basically has two separate highways and double the on-ramps. What that really means is it's a master at multitasking. So if your CPU, your AI accelerator, and your camera are all screaming for data at once, DDR5 can handle it all way more gracefully. And then there's the sheer size of the tank, right? The capacity. As AI models get bigger and bigger, the amount of RAM you have becomes a hard physical limit. DDR5 lets you pack way more memory into a small device. This can literally be the difference between a system that runs like a dream and one that just crashes and burns. Of course, all this awesome performance comes at a price. There's some real-world trade-offs you got to think about. First, the cost. DDR5 is going to set you back a good 30 to 50% more. Second, power and heat. It can run hotter, which is a huge deal in small, fanless designs. And finally, and this one is a biggie, compatibility. You can't just drop this into an old board. Nope. You need a whole new modern setup, a new CPU, and a new motherboard. All right, enough with the spec sheets. Let's bring this down to earth. When would you actually pick one over the other for a real AI application? Let's walk through a couple of examples.
Okay, scenario one. Picture this, a smart security camera. Its job is pretty simple, right? It watches a single video feed, runs a lightweight AI model to spot people or packages, pretty standard stuff.
So, what are the demands here? Well, the workload is pretty modest. We have one video stream, a small AI model, and the biggest priorities are keeping the cost and the power draw as low as possible. The system is way more likely to be bottlenecked by its little CPU than its memory bandwidth.
And so the verdict here, it's a no-brainer. In this situation, spending the extra cash on DDR5 just doesn't make any sense. The extra bandwidth would just sit there doing nothing.
For these simple, cost-first systems, DDR4 is absolutely the practical and stable choice. But now, let's totally flip the script. Imagine a beefy industrial computer on a factory floor processing, say, 4 high-res camera feeds at once for quality control. This is a whole different animal.
Here, the memory is just getting hammered. You've got multiple firehouses of high-res data constantly pouring in. The main goal is to keep a high frame rate on every single camera, and that means memory bandwidth is king. It's everything. This system is almost certainly memory-bound.
And this is exactly where DDR5 gets to show off. If you're in a spot where adding just one more camera makes your performance tank, DDR5 gives you that extra highway, that headroom you need to break through that barrier and scale up. It's the key to unlocking the real potential of a setup like this.
So this leads to a question I see all the time, and it's a great one. It pits speed against size. If your budget is fixed, what's the smarter play? A smaller amount of the faster, newer tech, or a bigger amount of the older, slower tech? It's a classic engineering dilemma.
And the answer, in almost every single case, is that capacity is king. Look, running out of RAM and forcing your system to use slow storage is a performance disaster. A system with 16 gigs of DDR4 will always outperform an 8 gig DDR5 system if the workload needs more than 8 gigs to run. It's just that simple.
Okay, let's pull all of this together. We can distill all these trade-offs into a really simple decision framework that you can use on your own projects. Think of it as your cheat sheet for choosing the right RAM.
So here it is. If your main problem is throughput from a ton of cameras, you need DDR5 for its bandwidth. If you're running massive AI models, again, DDR5, because you need that bigger capacity. But if you're on a super strict budget or you're locked into an older hardware platform, DDR4 is your guy. And hey, sometimes the choice is made for you if your CPU only supports one or the other.
You know, when you really get down to it, this whole thing brings us to the most important takeaway of all. It's about changing the question you're asking. The real question isn't just which one is faster. It's where is my system actually choking? Is it compute? Is it cost? Or is it the sheer fire hose of data I'm trying to manage? Once you answer that, you've got your answer. So, what's your bottleneck?